It's been a while since I made a recording of a CodeFights tournament. Here, I will join one and see how I do. And I'll try to do a better job of maybe after to explain some of my thought process. Let's see. Sensitive is really fast. Um, oh, let's go. So CodeFights expanded their I believe this is the formula for a leap year. See, he's already beating me. Sensitive. Oh man, this might be a really easy set of problems. So I actually don't do that well when the problem set is. Just brute force it. Wait a minute. I'm writing the solution to another. I'll skip this one for now. All right, I'll go back to this one first. Let's see. This one's actually not that easy. Hmm. Wow, this was correct. Yeah, this guy's sensitive. He's pretty fast. What took me 7 minutes and 20 seconds took him 2.5 minutes. So, uh, CodeFights expanded their tournaments to have uh, so they have one problem where it's a bug fix, just like before. Second problem is fill in the answer, and then they have three write your own code problems. So this first problem is determine if a given year is a leap year. So most of these problems are actually repeats. So I've seen all of these problems. So it's just like just mindless practice almost to just give myself some practice. And I know the rules to leap years just because part of the reason is because I've seen this problem multiple times. So a leap year is a year that's divisible by 4, but not 100 unless it's divisible by 400. So so basically it's just this. It's divisible by 4, but it's not divisible by 100, or it's divisible by 400. And one interesting note here is that the double and, the logical and, takes precedence over the logical or. So this is actually equivalent to to putting brackets right here. A lot of people may not even know this, but there is an order precedence here, and gets precedence over or. So basically, that was problem number one. Problem number two is basically output this sequence, arithmetic sequence, up until a certain number, and this one's not that hard. In this problem, it says give me integers n, l, and r. Find the number of ways to represent n as the sum of two integers that are in between l and r, basically. And here, um, it's basically just a single expression to give you the answer. So if n over 2 is between L and R, then uh, then you potentially have an answer. You have a non-zero answer. Otherwise, it's 0. So if n over 2 minus L plus 1 is positive, and R minus n over 2 is positive, then you actually have an answer. And the answer is just the smaller of the two quantities, n over 2 minus L and R minus n over 2. And what else can I say about this particular problem? I mean, the actual indices are a little tricky. You just have to know exactly when to sort of add 1 to get your desired result. It's, when you work with these numbers enough, you'll know like exactly when to add extra 1 or not. Given two strings, check whether it's possible to rearrange the characters of the first string in such a way that it becomes equal to the second one. So basically, if you sort both strings and they're equal, then you should return true. Otherwise, you return false. Here, you've intercepted an encrypted. So this one's actually a little hard. So based on my I'll read the question out loud first. You've intercepted an encrypted message, and you're really curious about its contents. You were able to find out that the message initially contained only lowercase English letters and was encrypted with the following cipher: that all letters from A to Z correspond to numbers from 0 to 25 respectively. The number corresponding to the ith letter of the encrypted message is then equal to the sum of the numbers corresponding to the first I letters of the initial unencrypted message modulo 26. So so basically, we're given the encrypted message, and we want to find the unencrypted message, and we know the encryption algorithm. So going to my algorithm real quick, result is going to be my answer, and I know that the first letter of the encrypted message is also the first letter of the original message. But for every other message, for every other letter other than the first letter, um, it's actually it's actually the value of that of the value of that the value of the letter of the original message is equal to the difference. So, for instance, the value of the first letter of the original message is the value of the first letter of the encrypted message minus the value of the 0th letter of the encrypted message. Basically, the difference between those two, modulo 26, and in C++, modulo, like, you can just check to see if it's less than 0, and you still add 26. Basically, you get that number modulo 26. Unfortunately, you can't just percent equal 26, because if negative 1% equal 26 in C++ is actually still negative 1. It's a weird, it's something with C++. So I got second place behind Sensitive, who did these 5 problems in 2.5 minutes, where I nearly took 7.5 minutes. Let's see. We can try another one. Sensitive here again, contending with us for the experience and the points from this tournament. He's from Indonesia, so right now it's 10:15 p.m. U.S. Eastern Time, so it's just early in the morning, Friday morning in Indonesia, and he's getting some coding practice in. It's pretty dedicated, I would say. Let's see. Given more practice, I hope to be able to explain my thought process better, and for coding enthusiasts out there, I hope to be able to be of a little help to you, because I do have some expertise in competitive programming, like writing like some mathematical, writing programs to solve like these little mathematical questions. I do have some expertise in this area, although real programming out in the real world, real software engineering, is very much different from this. All right, let's go. Here we go. Let's see where the bug might be. I believe it's here. This one's hard. Yikes. It's a variable number. I'm not sure if I got this correct. In fact, I don't have it correct. I need to reverse. I need to. Huh. All right, I'll skip this one as well. What does not compile? So let's see here. This one will be shifted by 0. Oh, that was silly. That was such a silly error. Consider a robot standing on a two-dimensional grid. It follows a sequence of instructions. Oh, leave a predefined square. Okay. So it starts at starts at 0, 0. So it's L up, down, keys, right. At the end, I want to return pause. To the left means 0 to minus minus. If pause 0 greater than negative bound, minus minus pause 0. Break. And the logic is almost entirely like this. I will have about a minute, less than a minute 30 to complete this. So if it's up, so it must be less than bound, 1. Plus plus pause 1. If it's down, 1 is greater than there. If it's to the right, it's less than bound. I have 55 seconds. Wow, I won. I beat sensitive. He did not do this question. Why not? Oh, I think I know why. He uses, I think I know why he didn't do this question. So um, he uses Python, if I'm not mistaken. Like yeah, he uses Python. And actually, I was going to say this kind of bit manipulation in question D is not conducive to Python. Actually, you know what? It's more likely that he had to go do something else. Oh, okay, he did do D. Like D is a little bit of bit manipulation. You see the shifting, and in Python, it's maybe not as convenient to do it, but you can just multiply by 256, multiply by 256 squared, and multiply by 256 cubed. So I don't think it's you can do it in Python pretty easily. I got first place. Great. You see, what his solution is. So I'll go over these one by one real quick. So this one basically basically the GCD function. There's a standard function for GCD to compute GCD of two numbers. It's a recursive implementation like this, and I just spotted the when I ran the original test, it showed me like basically I spotted this error pretty quickly, just sort of by luck. Here, given integers n, l, and r, find the number of ways to represent n as some. So we solved this problem in the last set of problems, but here we're only asked to fill out this one portion, and it's b less than or equal to r right here. It's pretty straightforward as well. So here, this I want to say is a logical problem where we're given the rules and we just have to sort of implement these rules, and basically, you know, I start the position at 0, 0, and in my head I know that I'm gonna in a loop increment the position variable, and at the end of the loop, I'm going to return position. And there's basically just 4 rules. Pretty simple. They're very similar to each other as well. And there are probably ways to make this more succinct, but in the time that I have, it's easiest to just type it out and copy and paste and do that kind of thing. So here, this problem is a bit of bit manipulation. Basically, so when I first read the problem, I thought that this input A always had 4 elements. So that would actually be even easier. That could be written in one line. But here, basically, you take the value 0 and you just add to it the elements of A shifted by 8, shifted by 16, shifted by 24. So you just shift each value by either 8, 16, or 24, or 0, and add all those shifted values together, and that is your answer. So Sensitive had trouble with this. I'm not sure he even printed values at some point. I think it's because in the style of Python, the sort of functional style, it's not easy to write the solution. Here, this is another sort of problem where it's sort of fairly simple. Basically, you want to split an array into 2 such that all the elements less than k are to the left and all the elements k or greater are to the right. But the order of them with respect to each other, for all the elements less than k, the order stays the same. Same goes for elements k or above. And basically, what I did is just first, in their respective orders, split them up into 2 different arrays or vectors in C++, less and not less, less than k and not less than k, basically. And then in the same order, I put every element from not less into less and return less. And that's, pretty straightforward. And we got first place, which is kind of cool. Barely though, like had a minute to spare. Maybe I'll do another before I go to sleep. Yeah, maybe I'll do one more. I'll try to think out loud a little more. Actually, I don't know. Maybe I'll go to sleep. Like if one more person join, I'll join, so it has at least 4 people. Oh, no one joined.